Hello, this is Douglas Rumbaugh, and welcome to episode 7 of my Linux Back to Basics command line tutorial. In today's episode, I'm going to be treating the concept of input-output redirection through the use of the data streams standard output, standard input, and standard error. Just threw around a lot of terms there. If you have no idea what I just said, hang on. By the end of this video, you should have a fairly good conception as to what those terms mean and how to use them. Okay, so first I want to illustrate what these data streams are in practice. I'm going to use the rather prosaic command of ls, and I'm just going to list out the contents of my home directory and press enter. And it should be no surprise what happens as a result of entering that command. But what did I really do? In the context of the standard input, standard output, standard error, what happened is I typed in ls space tilde, list out the contents of my home directory, and when I pressed enter, this string was sent from essentially my keyboard into the bash shell. It was read in from standard input. Bash parsed the command, figured out what it was doing. The command itself, ls, is the program I'm executing, and then, of course, the tilde is the argument that I passed the program. Bash sorted that out. It executed ls with the given arguments, and then printed the results to the screen. And when it did that, what it was doing is it was writing the output of the program to standard out. From this, we can glean that standard input is defaulted to the keyboard and standard output is defaulted to the console display. Standard error works in much the same way as standard output, except instead of receiving program output like this, standard error is going to receive error messages. So if I were to try and run my package manager without logging in as root first, this error message pops up. And this error message is printed to standard error, which also defaults to the console. I'll show you some evidence that that is standard error and the other one is standard output as we move forward here. Okay. So how can we take advantage of this knowledge of what's going on behind the scenes, and they have a very simplified version of what's going on behind the scenes? Well, Bash provides us with some useful tools that allow us to manipulate standard input, standard output, and standard error by means of what is known as redirection. So in order to do this, you need to use redirection characters or redirection operators, depending upon what you would like to call them. The most commonly used one, the one that I most commonly use, is what's known as the output redirect, and that is simply a greater than sign. In practice, what you can do with it is say, all right, I'm going to run the ls command passing it my home directory as its argument, and I'll just press enter again. No surprise what happens there. But what if, for some reason, rather than looking at it at this very moment, I wanted to create a log file containing the contents of my home directory over time? Well, I could very simply just copy, highlight it all and copy and then paste it into a text file, but that's a very inelegant solution. There's a much more elegant, simpler, less time-intensive way of doing it, and that is output redirect. So if I simply put a greater than sign after the command and a file name, we'll call it list.out, when I press enter, you'll note that list did not print the contents of my home directory to the screen. So where did it go? And I'm sure by now you have a pretty good idea of where it is. So if we just open up list.out, you will see that indeed it contains the contents of my, well, I keep saying the contents. It's the names of the contents of my home directory. You know what I'm talking about, though. So that all went to the file instead of to the display. Let's do it again. Okay, so I've run the list command twice, and both times I redirected the output to this list.out file. However, you'll see that I have 39 lines in this file, which is the same that I had to begin with. Nothing's been added. Now, why is that? The output redirect with one greater than sign overwrites the contents of a file. So when you redirect the output of the list command in this case, or any command that produces an output to a file, if the file does not exist, Bash will create the file for you and then throw the output into that file. If the file does exist, Bash will look at the file, delete everything inside of it, and stick the new output into the file. So what's happening that's causing our file to not actually gain any length, have the second set of records, is that this is the output of the second list command I ran. The output from the first one has been lost. And if I had been doing something other than list, actually I can even just to demonstrate this further, if I were to just do a list of the contents of my current working directory instead into list.out, you will see that I've lost the contents of my home directory. That's no good. We want to create a log of the contents of my home directory, not just a one-time shot. Fortunately, there's another kind of redirection, and that is using two greater than signs. This one is append. So again, if the file doesn't exist, Bash will create a new copy, or not a new copy, but create a new file and put the output into it. And if the file does exist, rather than deleting everything inside the file, Bash will append the text. That is, take the text and the text generated as output by the function or the program and stick it onto the end of the file. So just to demonstrate this, I will run a list of my home directory and append it to list.out. So if we go into list.out again, you'll see up here I still have what was originally in the file, and I have a whole bunch of other jazz. And if I were to run it again and open the file again, you'll see the line length has gone up, and I have 2 copies of everything in my home directory. Okay. So that's redirecting standard output. How do you redirect standard error? Say I wanted to create a log file of the errors from my programs when they run, and this is something that you not have to do, but that I've had to do on a number of occasions with some server administration that I've been working on, and using a utility known as cron, which I will cover in another video, but essentially it just allows you to run commands in the background at a specified time. And when you do that, you lose the ability to really see the output of the function usually, or the output of the program. I keep saying function. It's the wrong word. I don't know why I do it. The output of the program. One way around that is to redirect standard error to a text file so that you can look inside of that text file and see any errors that may have popped up. So remember when I tried to run pacman? Without sudo or without logging in as root, it throws this error message. So I can, by placing a 2 followed by the redirection character, redirect standard error to a file. In this case, we'll call it error.out. And you will see that my error message has been written to the text file instead of showing up on the display. All this junk here is just Vime trying to understand in plain text the color. Whoops. The error here was in color, and Vime doesn't handle that well. And this follows the same rules as the standard output redirect. So you will need to use 2 greater than signs if you want to append text. Otherwise, it will overwrite. And another Another thing to note is that if you wanted to be extremely kosher about it, hold on, let me just get rid of all this. And this is simply being presented for completeness' sake, but that isn't technically the proper standard output redirector. It is, but if you place a 1 in front of it, that is the official standard output redirector. I suppose that the creators of Bash understood, though, that you want to redirect output a lot more often than error. So if you just drop the 2, or if you drop the 1, it's less to type and easier to understand. It's also worth noting that if you, instead of a 1 or a 2, if you put an ampersand, a shift 7, in front of the redirect character, it will redirect both error and output. Okay, so that is output and error redirection. How about input redirection? Well, to really demonstrate this, I want to introduce a new program to you, and that is called Grep. And what Grep does is it reads from the standard input and searches the standard input for a specified string or series of numbers or characters. It will also allow you to implement regular expressions, regex, which I will not cover in this video. But just as a quick demonstration, if we were to use grep as default without any special stuff, you just type in grep and then what you want to search for and press enter, and it will throw you down onto the next line, and you can type in some stuff, and then whenever you press enter, it will go through and highlight, in this case, all the A's. So we'll abort that. Well, that was actually a control D, not a control C. Either one will work in this case. Okay. So how can we use grep in a more useful manner? Because that functionality that I just demonstrated is not terribly useful. Well, I've pre-created this search file.txt, which just has some lines of text in it and a few numbers. So let's look for some things within search file.txt. Again, what about A? So if we can type in grep A because we want to search for the letter A. And we want to use, instead of our keyboard as standard input, that file as standard input. So a less than sign serves as the input redirection operator. If we type in the less than sign followed by search file.txt and press enter, grep will run through that text file and print out all of the lines that contain an A, as you can see here. Okay, that's all I'm going to talk about the redirection characters for this episode. There's probably a lot more to it, and I could go a lot more in depth, but we're hitting 13 minutes now, and I'd like to keep this series, again, as I've mentioned on previous occasions, this is back to basics. It's not an advanced technical tutorial, so we'll leave it at that. But there is one more operator that I want to introduce and demonstrate in this video before I call it quits for the day. And that is what is known as the pipe. Now the pipe is shift backslash, it's the straight line, and it serves essentially, and this is a very non-technical definition, to link two commands end to end. What do I mean by this? You can execute a command and then through the use of a pipe, pass that command's output into the input of another command. To demonstrate this, I'm going to introduce yet another utility, program, what have you, and that is cat. Now, in addition to being an adorable animal, cat is the concatenate program on Unix and Linux systems. And it does exactly what the name says. It concatenates files together. Concatenation is simply the process of joining together end to end. So let's see. I have this list.out. I have a couple files in here. If we were to cat list.out and search file, what's going to happen is it will read in from those files. This is search file, this is list.out, and it just combines them and prints them to the standard output. So instead of using the input redirector to go through search file.txt with using grep, you can also use cat and a pipe. So if we do cat search file.txt pipe grep a, you will see that I get the exact same output as I get whenever I do that. This is perhaps a bad example. Another way you can use the pipe is for something that give me a moment here. I need to think of my words. For a command that prints out a lot of output that you want to parse through without having to write it to a file and then using redirecting an input or that cat method. A good example with this is the PS command. That's actually a horrible argument example, so we'll do this. There we go. So this is going to print out every process that's running on my computer. And I will discuss PS in greater detail in a future video, but essentially I use it usually if a program stops responding, so I can get what's known as the process ID of that particular program, the PID right here, which is what you need in order to abort the program. We can do a PS AUX, which prints out everything on the system, and search it for a particular thing using grep and only print out that particular program. So say I wanted to search for what I believe I have Terminator running a couple of times. That's my terminal emulator. You will see that it runs through and finds every instance of Terminator within the PS, which interestingly enough also includes the grep command, which is this last line here. But ignoring that last line, you have all the terminal emulators that I have open along with their process IDs. So if one were to stop responding, you can kill it. That's just a practical use of the pipe and grep. Okay, so I'm going to call that an end for content in this particular video. To quickly recap, I introduced the concepts of the data streams standard output, standard input, and standard error. Standard output defaults to the display and is the output of the applications that you run. Standard input defaults to the keyboard and is where the console or a program reads input from. And standard error is where an application puts error messages and defaults once again to the console. You can redirect these using the redirection characters. Greater than signs redirect output and error. A 1 followed by a greater than sign or just a greater than sign both serve as standard output redirectors. A 2 followed by a greater than sign serves to redirect standard error. And an ampersand, that is shift 7, and the greater than sign redirects both. And you can redirect these to a file. It will create the file if it doesn't exist. If the file does exist, 1 greater than sign on any of those types of redirection I have mentioned will overwrite the file, and 2 will append the new data to the end of the file. And yes, I realize that was a redundant statement. In addition, you can redirect standard input using a less than sign. This is the input redirect command. And you can use the pipe to essentially link 2 commands end to end and use the output of the first as the input of the second. All of these are very useful. They become incredibly useful in bash scripting. The redirector is more so than the pipe. The pipe is a convenience thing for typing on the command line. At least that's how I use it. But it's very useful information to have. So, As always, I'd like to thank you for taking the time out of your day to watch this video. If you found this interesting or useful, please like the video and comment down below with any questions that you may have. I will do my best to answer those, as well as any feedback. If I made a mistake, point it out to me, please. That's the only way I know that I did something wrong and can fix it. And also, if you enjoyed this, please feel free to subscribe to my channel so you can keep track of all of the new videos that I upload. I don't upload them super frequently, but it will make it easier for you to get your hands on them so you can see them. All right. I hope you guys have a wonderful rest of your day, and I will see you all in the next video that I release. So once again, thank you for watching.